Alright students, this is part 2 of going over exercise U2A01b. So in part 1 we went over solving the quadratic equations by factoring, and so now we're on the bottom half here. So we are going to solve this by using the quadratic formula as the instruction here is telling us to. So what we're going to do is I have n squared plus 10n minus 39 is equal to 0. So what are we to do here? So what we're going to do, okay, is we need to identify what exactly is a, b, and c. So I noticed that a is equal to 1, b is equal to 10, and c is equal to negative 39. So having this understanding, what I'm going to do then is, okay, I'm going to solve for what n is equal to, right, to cause all of this to go to 0. Well, n, as it turns out, will equal to negative 10 plus or minus square root of 10 squared minus 4 times 1 times negative 39, all divided by 2 times 1. And of course we got to perform a little bit of simplification here. So this is going to turn into negative 10 plus or minus square root of, well, 10 squared is 100, and then next I have a double negative, so 4 times 39, what is that? That looks to be, let's see here, 4 times 9 is 36, so 156. So I end up with 256 inside, all divided by 2. And now what we got to consider is, well, what two numbers multiplied together get you 256? 256, I believe, is that 16 squared? Let me just double check that. So I want to jump to my calculator. See how sometimes math teachers need calculators too. And just so that everyone knows, my Achilles heel is computation. I can't do simple math in my head. So it is in fact 16. So we're going to go back over here. So this is in fact negative 10 plus or minus 16 over 2. And this simplifies down to negative 5 plus or minus 8. So what is this? This is going to be negative 13 or positive 3. So n is equal to negative 13 or positive 3. All right, moving on. So next one here, I have I have n squared plus 10n minus 26. Okay, so again, we need to be able to identify what is a, b, and c. So in this case here, I have a is equal to 1, b is equal to 10, and c is equal to 26, negative 26. So again, n will equal to negative 10 plus or minus square root of 10 squared minus 4 times 1 times negative 26, all divided by 2 times 1. So what is this all going to turn into? This is going to turn into negative 10 plus or minus square root of 100 plus, let's see here, 26 times 4, that would be 104. So I end up with 204 over 2. What is the square root of 2 over? We need to reduce this, okay? So when we reduce radicals, okay, we got to consider, is there a perfect square that divides evenly into both, into 204? And I immediately see that 204 is divisible by 4. So 204 divided by 4 is 51, right? So this is negative 10 plus or minus square root of 4 times 51, right? Divide by 2. And square root of 4 is really 2. So I end up with negative 10 plus or minus 2 square root of 51 all over 2. And the final answer is going to be n equal negative 5 plus or minus square root of 51. Okay? All right, next, I have p squared. Actually, let's do another one. Let me see here. Whoops. Let's see. Let's try one of these. Yeah. Okay. So what we're going to do is, let's do number 26. So we want to add, we want to bring over all the different variables, all the different terms, and set it equal to 0 so that we can apply the quadratic formula. So what would happen then? Okay, so if I add over 4n squared, I'll end up with n squared. And I'm going to add over 9n, so I'm going to end up with 12n, so it's plus 12n. And I'm going to subtract over 3, so I end up with plus 11 is equal to 0. Okay? So if I do this, okay, I'll end up with, actually, this A is equal to 1, B is equal to 12, and C is equal to 11. So what would make n then? N is equal to 12 plus or minus square root of 12 squared minus 4 times 1 times 11. And all divided by 2. Okay? So what we want to do is we want to, again, reduce. So I get 12 plus or minus 12 squared, that's 144. 144 minus 44, well, that's just 100. And square root of 100 is just 10. So I end up with 12 plus or minus 10, all divided by 2. So this is just really 6 plus or minus 5. Or really the answer is 1 and 11. Right? So it's either, so n, as it turns out, is either 1 or 11. Okay? I'm sorry, I made a mistake, and that's what happens when I talk to myself. B is actually negative 12. So this is negative. Okay. So this should be negative 12, and if that's the case, that's negative 6. And then so the answer is actually, in fact, negative 1 or negative 11. So you know why I paused there for a moment, right? I looked at my answer. I didn't, and I didn't just leave it at that because I saw the answer. It didn't really make much sense. And this is actually a learning experience. Let me just briefly talk about this. This equation, okay, just by the way it looks right now, okay, if you have enough experience, okay, you should be able to recognize that that is something that's factorable. Right? Can you see it? Right? This is actually something that's factorable. And if it is factorable, then the roots should turn out to be something really nice, which it did. Okay. However, I knew, again, this is from experience, that this should turn into n plus 1 and n plus 11, right? Which meant that the roots had to be negative and not positive. So again, sometimes if you go through your computation and you arrive at a conclusion, just pause for a moment and just observe to see whether or not it makes any sense. Okay? Let me just see if I wanted to do any other examples with you guys. No, it looks like that's it. That's all I wanted to do. Okay.